Okay. Good evening, everyone. Today I'm excited to present our data warehouse and data mining mini project that is a Bengaluru house price prediction using a machine learning model. This project demonstrates how we can apply data mining and machine learning concepts in our daily scenario. Predicting house prices in our India most vibrant cities like Bangalore. We had collected the data. This means the real estate industry is vast and full of variables in cities like Bangalore. Prices vary drastically even within a small regions also. Because due to some information technologies like IT companies, due to all this, influenced by the numerous factors like locations also, size, proximity to school or metro, and even the surroundings infrastructure. In such a volatile market, predicting prices manually is very difficult, you know, and prone to inconsistency also. That's where the data mining and machine learning comes into the picture. Our objective was to build a model that could analyze historical housing data and predicting the price of a house based on the inputs like location, square footage, BHK value, and number of bathrooms. And the outcome is a price. That means it can serve buyers looking for a fair deals. Sellers aim to price accurately, and brokers needing a quick estimating tool. Here, the problem is uh, can we accurately estimate the price of housing in Bangalore given some basic details? Tell me. We reframed it as a supervised regression model where we train a model using a known inputs and outputs. Features here, the features are a location, BHK value, and the output is a price, housing price. Once the trained, the model can predict the price of any new set of features. Now let's see the data set overview. The data set we are having a total number of features are 13,300 plus entries, and a number of columns are 9. But we had taken a location, a size in BHK, total square footage, number of bathrooms as a training set. That is, those are given as inputs, and the total and for the given features, the output is the price in lakhs. We are predicting the price in lakhs. Now here we are using libraries like NumPy, Pandas, Matplotlib for visualizations, Seaborn for visualization, and training the dataset using the three models like Lasso, Linear Regression, Decision Tree. Here we are giving the input. We are taking Bangalore housing dataset, which contains the features like area type, availability, locations, a size, a society, total square footage, uh, bathrooms, balconies, and the price given out 39 like that. And total number of columns are 13,320, and number of columns are 9. Here we are dropping the null values. So nearly some for 5,000 columns rows are dropped. Here we are converting the value into the square footage. Here and seeing how many are null values. A total number here we are containing very no null values. And now let's see this. Here we are counting number of different types of areas and their count. Here build-up area contains the count of 2,418 value. Carpet area contains 87. Plot area contains 2025. Super built up area contains 8,790 count value. Here we are plotting the graph for total square feet versus a price. Here we are drawing the scatter plot for the bathroom versus a price, balcony versus price, and BHK versus price. Here we are identifying number of columns. Here we are removing the price per numerical value if it is present. Here this is the code given for the numerical columns versus price scatter plot. Actually, the main theme of the data pre-processing is we are handling here the missing values, converting the size to BHK value, standardizing the total square footage, pricing per square footage, categorical encoding, outlier removals, and all these come under the data pre-processing. Here, we're dropping less impact columns that are area type, society, balcony, availability, since they are having very low correlation with respect to the price. So we are dropping that, and we are storing in the data frame of 2. And here we are drawing the heat map with respect to total square footage, bathrooms, price, BHK with respect to the total square footage. Here square footage, bathroom, price, and BHK, and all these are done for seeing how much they are related to target value. The correlation is one, that means it is strongly correlated with respect to the output, that is a target value. If it is having -1, that means it is completely opposite to the target value. If it is 0, that means it is neutral, either neither case. Here we are seeing null values. How many in the data frame 2? How many are null values? And here we are dropping. Here we are seeing in the data frame 2 for the size column, how many features, how many classes are different. That means 2 BHK, 4 BHK, 4 bathroom, all this. Here we are selecting, we are taking this. If the BHK value is greater than 20, then we are taking that data frame value. That means we can see here 27, 43, they are greater than 20. And now we are converting that value into the float value. And here converting the square data into the numerical data. And we are seeing the total square footage value. How much square footage? Like 1056. All these we are printing. Here we are taking a particular row, that is 30, and printing their values. Here we are adding a new column, that is price per square footage. Here we are calculating with respect to a price, that is this, and total square footage. That means we are taking a price per square footage. Here you can see, here total square footage is 1056 into, this is a square footage, and price value is 39. 39 into 1 lakh, 39 lakhs divided by 1056. That means we are getting price per square footage and adding it to the new column. Here you can see here. And in the data frame 2, you are seeing how many locations are unique. And here you are counting which locations are more popular in the Bengaluru. That means we are grouping it. Whitefield contains 541 count. That means it is more popular. That means it is having a high price in the marketing. And all these are not a popular. That means we can remove it because we can add them into the others. That means they are completely the outliers. Here we are getting topmost. That means very popular locations in the Bangalore cities. We are taking it top 20 or printing. Here we are drawing a bar graph with respect to the popular cities and their count values. Here the popular city you can see is Whitefield, Sarakpur Road, Electronic Cities, all these. Here I told you no before because the count is very one. That means they're completely the outliers. We can add them to the others field also. And this is the code written for that. Here analyzing the outliers. Here how do we analyze the outliers means in the data frame given a total square footage if you divide by the number of bedrooms BHK values if they are very less than 300 that means they are completely outliers. If we and we are selecting the value which is greater than 300 that means these are not the outliers and we are considering into the data frame of 5. Now we will describe price per square feet as that means what is the price per square feet in terms of count, mean, standard deviation, minimum value, what is the maximum value, all this. Here nearly we removed some 2000 records that are completely the outliers we can say. Removing based on the standard deviation, we have the high and low cost. Here we are removing a price per square footage outlays. Here before it is 12,568, and now we done until we done to 10,355. That means we removed nearly 2,000 records, 2,500 records. Now we can see the graph of before removing the outliers versus after removing the outliers. You can see here sharp extreme value, but it is a vast spread. And you can see the scatter plot also. Scatter plot versus after removing versus before removing. Here we are taking for a particular location how many 2 BHK how much 2 BHK total and 3 BHK with respect to the price and the total square feet area. And for location available, we are seeing same price and the total square feet value. And before we saw that 10,335 by removing all the outliers. Here we will be removing a BHK which are very less than which are greater than the 3 with respect to the mean and the standard deviation and the count method. Here you can see a scatter plot. And the price per square feet versus count histogram. Here you are taking here bathrooms which are less than BHK plus 2 values. And we are taking it into the data frame of 8. Here we remove nearly 3,000 records. Before we are having some 10,355 records, I think so. And now we remove to nearly 3,000. And the current dataset contains records of 7,309 records. And we dropped two features. Now we will be dropping a size, a price per square footage because before we had done for we added price per square footage, so we can remove it now. And now we use it one hot encoding method. You can see here. Now you can drop the columns which contains the other values in terms of columns. Now here we will be dropping a location and a column, location column, and storing them into the data frame of 11. Now with respect to the data frame 11, that means now we are building the model with respect to 7309. That means we removed many records. That means initially we contains some nearly 13,000. Now we'll be training the model on the data frame 11. You can see here. Here we use the model, a linear regression model. We are using sklearn for train test display, for splitting the data. And the model used is linear regression model. Here you can see the accuracy of nearly 81%, 81%. And here you are using a cross validation method for the linear regression method. You can see R square values. Now we will be using lasso method and also decision tree. Since we should compare, so we are using regression models, all these. This is a regression model, lasso model, decision tree, and the output given for the regression, for the linear regression is 84%. For the lasso, we are getting 69%. For the decision tree, we are getting 75%. That means linear regression is giving more accuracy. That means 84%. Now we will be predicting the value. For example, for first phase JP Nagar, you are inputting the square feet as 1,000 and bathrooms required are 3 and BHK value is 3. Then what is the price predicted in that location? That means we are getting 96 lakhs. For the Indira Nagar and square feet value is 1,000, bathrooms required are 2 and BHK is 2, then the required price, rating price is 203 lakhs. That means this location is more popular. So we are having some high price. We are using a pickle because to dump the model to the file. While this JSON is done for inputting, that means to store the input values. And in our project, with the tools and technology used are Python, Pandas, NumPy, Matplotlib, Seaborn, sklearn, Jupyter Notebook, and Google Colab also. Okay, thank you.